Today's lesson, general method of preparation of aliphatic amines. In this lesson, we are going to learn lithium aluminum hydride in detail, 1-degree amine from nitrile, mechanism of the reaction, and finally 2-degree amine from isonitrile. So let's get started. The very first point is lithium aluminum hydride in detail. Let's see the matter. Lithium aluminum hydride, which is in short lithium aluminum hydride. This is white in color and solid at normal condition. This is discovered in the year 1947 by Feinhold, Bond and Clesinger. Lithium aluminum hydride is prepared from lithium hydride and aluminum chloride, and here lithium chloride is produced as byproduct. Now let's see structural formula of lithium aluminum hydride. Here lithium plus and hydride ion, 4 molecules of lithium hydride, and aluminum chloride breaks to aluminum 3 plus 3 chloride ions. Here aluminum 3 plus combines with 3 hydride ions. As charge of aluminum is very high, that is 3 plus, so this aluminum hydride converts to covalent compound aluminum hydride, and another hydride here forms coordinate covalent bond with aluminum hydride, because normally aluminum hydride is a kind of Lewis acid. That is, around aluminum there are 6 electrons, which is not octet fulfilled. Aluminum wants to receive another pair of electrons. That is why this hydride forms coordinate covalent bond with aluminum. Now this is tetrahydroaluminate ion. This tetrahydroaluminate ion bonds to lithium ion. So this is a kind of inorganic compound having covalent bonds, coordinate bond and electrovalent bond, that is ionic bond. Lithium aluminum hydride contains these kinds of bonds: ionic bond, covalent bonds and 1 coordinate covalent bond. Now let's see working function of lithium aluminum hydride. Lithium aluminum hydride, which dissolves in dry ether. It is not dissolved in water. We will learn the reason behind this later. When lithium aluminum hydride is dissolved in dry ether, then it ionizes to lithium ion and tetrahydroaluminate ion. Again, this tetrahydroaluminate ion ionizes to hydride ion and aluminum hydride, which is known as alane. This is also called alumane. So in this way, lithium aluminum hydride produces a hydride ion that participates in a reduction reaction. Hydride ion, which is basic in nature, when water is used as solvent with lithium aluminum hydride, then hydride ion produced from lithium aluminum hydride will react with water vigorously, because this is basic in nature and water here acts as acid in contact with base to form hydrogen gas and hydride ion. So to protect this reaction, water is not used as solvent. Rather, dry ether is used as solvent for lithium aluminum hydride. Dry ether is actually diethyl ether, which is non-polar solvent, sometimes called inert solvent. Because of its inertness, dry ether is used as solvent for lithium aluminum hydride. So simply lithium aluminum hydride provides hydride ion for reduction reaction. Let's move on to the next point. Now the point is 1 degree amine from nitrile with the help of lithium aluminum hydride. Here this is nitrile. General formula of nitrile. The first member is CH3CN, which is called acetonitrile. This is also called methyl cyanide or cyanomethane. When this methyl cyanide is treated with lithium aluminum hydride, then 1 degree amine is obtained. Let's see the reaction. Methyl cyanide, lithium aluminum hydride, dry ether. Here lithium aluminum hydride reduces this compound cyanomethane to CH2NH2, 1 degree amine, ethyl amine or aminoethane. Here carbon gets 2 hydrogen atoms, nitrogen gets 2 hydrogen atoms, and ultimately 1 degree amine, aminoethane is formed. This reaction is normally showed in this way. Methyl cyanide, nascent hydrogen, lithium aluminum hydride in presence of dry ether, 1 degree amine is formed. Here this reaction is showed normally in this way. Now let's see mechanism of the reaction. Now the point is mechanism of the reaction. Reaction between nitrile and lithium aluminum hydride. Let's see mechanism step by step. Step 1, lithium aluminum hydride in dry ether ionizes to lithium ion and tetrahydroaluminate ion. Step 2, tetrahydroaluminate ion changes to hydride ion and aluminum hydride, which is known as alane or alumine. Now at step 3, the main component, that is nitrile, suppose cyanomethane, main reactant which is attacked by lithium ion and hydride ion in this way. That is, here this functional group, cyanide group or nitrile group, acts as initiator of the reaction. Here electronegativity of nitrogen is 3.1, carbon is 2.5. So covalently bonded electrons move towards nitrogen. As a result, over nitrogen negative charge develops and over carbon positive charge grows up. Positively charged carbon is attacked by hydride ion and negatively charged nitrogen is attacked by lithium ion, and as a result this is formed carbon, then hydrogen, carbon, this hydrogen. Here carbon nitrogen triple bond changes to carbon nitrogen double bond, nitrogen with lithium, nitrogen with lithium. This is called imine salt. Now step 4, this imine salt interacts with aluminum hydride. This is a kind of Lewis acid, aluminum hydride, which has tendency to accept one pair of electrons. Here from nitrogen, aluminum accepts one pair of electrons, and as a result around nitrogen electron deficiency is created. So for this reason these pi bonded electrons move towards nitrogen, and as a result over nitrogen positive charge develops. At that time these hydrogen with covalently bonded electrons move towards carbon, and finally this is obtained CH3, carbon, carbon, one hydrogen. Here another hydrogen is added, then carbon nitrogen double bond changes to carbon nitrogen single bond. Here lithium, nitrogen with this portion AlH2, nitrogen with AlH2. So this is obtained. Now this compound is hydrolyzed with heat. Let's proceed. Step 5. At step 5 this is hydrolyzed. CH3, hydrogen, hydrogen, nitrogen, lithium, AlH2. This is hydrolyzed with heat. In presence of heat, this is ionized to hydroxide ion and proton. Here, because of the higher electronegativity of nitrogen from lithium, these electrons come towards nitrogen, then nitrogen gets negatively charged, and after that this proton combines with nitrogen and lithium becomes positively charged. This combines with hydroxide ion, which is released as lithium hydroxide, and this is obtained CH3, H, nitrogen, here hydrogen, nitrogen, this hydrogen, and here AlH2, AlH2. Hydrolysis continues with heat. Again it is ionized to hydroxide ion and proton. Here nitrogen is linked up with aluminum metal So these electrons come towards nitrogen, then it becomes negatively charged, aluminum becomes positively charged. This negatively charged nitrogen receives this proton to form this compound. Hydrogen, hydrogen, here nitrogen, nitrogen with one hydrogen. Again, nitrogen combines with another proton which is produced from water, this one, and here another compound is formed as byproduct, AlH2OH, AlH2 plus OH minus. So this is the compound which is obtained from the reaction. This is 1 degree amine or ethyl amine or aminoethane. This is 1 degree because here amino group nitrogen is linked up with only one carbon atom. That is why this is called 1 degree amine. In this way, 1 degree amine is prepared from nitrile alkyl cyanide through reduction by lithium aluminum hydride. Let's move on to the next point. Now the point is 2 degree amine from isonitrile through reduction with lithium aluminum hydride. Here this is general formula of nitriles and this is general formula of isonitriles. Let's consider one isonitrile, CH3NC. This is isonitrile, methyl isocyanide, which is treated with lithium aluminum hydride in presence of dry ether. Then this nitrogen gets one hydrogen and this carbon gets 3 hydrogen atoms, and ultimately we get dimethylamine, which is a kind of 2 degree amine. Here nitrogen is linked up with 2 carbon atoms. That is why it is a kind of 2 degree amine, dimethylamine, which is produced from isonitrile with the help of reducing agent lithium aluminum hydride. In case of isonitrile, valency of carbon is 2. We know carbon has 2 valencies, 2 and 4. Here carbon used 2 valency. That is why nitrogen double bond carbon. This is isonitrile. This is all about general method of preparation of aliphatic amine from nitrile and isonitrile with the help of reducing agent lithium aluminum hydride. Number today, thank you very much.